This is Andrew Leonard, and this is my Lab 4 for circuit simulations. So the software we used in this lab was a circuit construction kit, and we wanted to simulate different types of circuits and observe how current, voltage, charge, and etc. reacts in different types of circuits, so series, parallel, and different components. One circuit we used was with two 1.5 volt batteries, one 47 ohm resistor, and one 100 ohm resistor, as well as two ammeters. The results we found in this lab was that the current on both ammeters is 0.2 amps, and the voltage across the 47 ohm resistor was 0.959 volts, and over the 100 ohm resistor was 2.041 volts, while the voltage across the ammeter and the wire is 0 volts, which makes sense because there's no resistance over these, or at least we assume so. However, on the batteries, there's a negative 3 volts across the batteries, which also makes sense because of the loop rule where the voltage across the whole system must equal 0 if you go in a loop. And as you see here to the right, this is where the different setups are pictured. So if we plot a graph of the voltage across the entire system, we see that the voltage increases across the batteries and it decreases across the resistors. And you start at 0 and you end at 0, which displays the loop rule. And the electric field is a negative gradient with electric potential, and that means the electric field is large where electric field is large. So as you can see here across the battery and the resistors, the electric field is quite large. In addition, the next type of circuit we did was an RC circuit, and it's a circuit with both a capacitor and a resistor. So we used a 10 ohm resistor and a 20 ohm light bulb, a 9 volt battery, and 200 microfarad capacitor. And what we observed was that when the capacitor starts off uncharged, the capacitor begins to gain charge and the light bulb becomes bright but slowly dims over time, which makes sense because the voltage across the capacitor increases over time while the voltage across the light bulb decreases. When the capacitor starts off charged but without a battery, the light bulb again starts off bright but starts to dim over time. When discharged, the current started off high but began to decrease over time, which again makes sense due to the loop rule and everything. So once observing, it takes about 4.5 seconds to charge the 10 ohm resistor and about 7.78 seconds to charge the 20 ohm resistor. So the time dependence of the charging, we can find out that the natural log of delta V over delta V initial is negative T over RC. And this is gotten by solving the differential equation of the system's loop rule equation. So the voltage of the capacitor minus the voltage across the resistor is equal to 0. From this we can get that the slope of the natural log delta V over delta V0 is versus T is negative 1 over RC. We tried to prove this by using a circuit with a 9 volt battery, 200 microfarad capacitor, and a 30 ohm resistor. And as you can see here, this is where we recorded all the data. And this was recorded the voltage of the capacitor over time. So as we plot this, we find that the slope is negative 0.1669. And this should be about negative 1 over RC, which is proven earlier. And using the values from the circuit, we find that 1 over RC is negative 0.1667, and the values are extremely close, which means that the graph displays the situation from the circuits correctly. So conclusion questions. What would have happened if we used a real ammeter? So a real ammeter would have had internal resistance, and therefore there would be a voltage and drop across the tool. This means that the voltage across the different resistors would be smaller, because there would be more voltage across the ammeter and therefore less on the resistors. How long would it take to charge a capacitor fully without a resistor? So to find this out, we have to set up the differential equation Q over C equals 9 volts, which is at the loop rule. And there would be no time term there, which would mean theoretically the capacitor would charge up fully instantly. I tried this on the software and it seems it would work correctly this way. Anyway.
Thank you
Very much, and this is my Lab 9. Thank you for listening.